Hey guys, welcome back to the channel. This will be part 2 on the 6.0 liter Crusader coming from New Jersey, Rick Sweden, line 6. He sent his computer and they resend it because after I think it's like a year and so, or almost a year and 2 months, they still have problems in the boat. He replaced the harness and it still has problems. At first, in the first video, I was not able to get the computer to run, and I'm like, okay, let me open it up to see what I find. Computer is looking pristine. I'm like, am I missing something in here? So, yep, it was a mistake of my part. I was using the 5057 signal. This is not. This is a computer that uses, the 5057 uses only one coil, one ignition coil. The 6.0 and the 8.1, 7.42 on the Mer Cruiser, they use a coil driver per each coil, so 8 coils injectors, 8 coil drivers, and then 2 batch of injectors, which we have here, but the computer is running. So I'm always very transparent. So the check was performed incorrectly on the first part, just because of the signals of the cam and crank, which are super important. Definitely, if you're not getting the correct synchronization, it will not run. And I was like, I got 5 volts. I can see the computer reading. The fuel pump was doing the prime. I'm like, what am I missing? But he also had, and that's what it, led me to believe it, because he had a cam sensor signal fault present in the history. But I was able to erase it, and that wasn't the issue. It was not the issue. This this boat is very important because that's the synchronization. That otherwise, it will not fire the coils or the injectors in the correct sequence, and it will start. But yeah, that's not the case right now. Let me see what faults we have, because I have four faults. Yeah, all this is a EST signal. I still got the cam sensor signal fault. Let me erase this. Yeah, you see the EST signal has an open circuit, and the reason the cam fault was there is because I was running with the other signal, and I changed that. So right now we only have those 2 faults. Those 3 faults. I'm going to let's select. We got 1,060.8 hours. So let me select 4 pits. I'm going to select the engine speed. I'm going to select the throttle, not the throttle codes, the throttle position percentage. I'm going to select the map, manifold air pressure, and see if I can select the injection millisecond on one of the banks, because I think this one gives bank 1 and bank 2, which not a problem, but we can only in Diacom select 4 pits to magnify, which is, I'm just trying to give you the best from the distance. So yeah, the computer is running. I'm going to increase the RPM to 4,000. Which is going really good. Let's put the throttle around 60%, 70, 60, whatever, right? And let me change the map to around 17%. And we can see the change on the injector pulse width. No problem, no difference. So I'm going to have the computer running. Right now I have run the computer for almost 6 minutes. I'm going to stop the video here. I'm going to let it run in idle for a while. Not an idle, in high RPM for a while. And then come back to the video to turn off, turn on, turn off, turn on. I absolutely don't see any problems with the computer. Injection milliseconds is reading really good. And it runs immediately, but I will turn it off, turn it back on as soon as we come back. All right, now the computer has been running for 11 minutes, no issues at all. And the thing that I am actually a little puzzled what problems he might have on the boat is that he has absolutely no way to communicate, and I have no problems at all. So let me bring this down to idle. You can see that it's coming down very nicely. All right, so let me bring the throttle to around 7%. That's what I usually put. We still got the same 3 full codes in there. I'm going to bring the map down to 12.5, 12.6. That's what I usually use for for idle, and that just changes the injection milliseconds. But yeah, nothing is in there. I'm going to power off. So we are losing communication, as you can see in there, and I'm going to let it completely lose the communication. So not going to start now. Just going to let it set no communication possible. It's going to try 10 times. And then it's going to give it the warning that the ACM is not responding, which is okay. That's fine. All right, so I'm going to come out of here. And we're going to select the computer back again from scratch, right? So I'm going to turn the ignition on. We got fuel pump prime, that is good. I'm going to select the computer as a MEFi 4. Click OK, and that will detect the computer, and it's detecting it every single time, no issues. And I'm connected back in. So as you see, we have almost 1060.9. Now is engine runtime 0 minutes because obviously I turned it off. But let's start it. And it starts immediately. And we only have the same 3 fault codes. The reason I was having that cam sensor again is because I used the wrong signal, and that's probably what he has. He has a problem, maybe, Rick, you might have a problem in one of the sensors, cam and crank. I will start there, but you not having communication, you're gonna have to check your harness from the computer connection all the way down to the rest of the harness that you replace. Something in there. This is pretty simple. All you have in the connector for where you connect your TechMate or Rinda is a power and a ground, and then the signal for serial data and diagnostic data, which you can run new wires, and that's what I would recommend. If you check your port and you have a good power and ground in there, I would just run 2 wires directly to the ECM ports or the pinouts for that. Let me just go there. In the meantime, we're doing this. Because I got all that information in here. I was working in somebody else, so let me go back to regular MEFi 4. And then these are the connections for 6.0 and 8.1. So the communication is in J12. Let me make this full screen. So you're gonna have the diagnostic test terminal in pin J12 and the serial data in J210. So these are just your 2 wires that goes over to that connector. You can just run new wires all the way to the back of that connector where you are going to plug your TechMate. Again, just check powers and ground with a test light. Make sure that they, nice and bright, and then run new wires so you are able to communicate. But if that is the problem, you might have other problems. And I mean, it's all I guess because I'm not there, I cannot see what you are seeing. So I will also recommend, if you can, use your phone, try to record short videos, upload it to YouTube or send it to me, and I might be able to help you, solve this puzzle in the boat, because this is running good. I always will let you to check main grounds and power to the computer. This is very important too. Make sure that you have ground in J113, J128, and J129. Those are the main grounds for the computer. And you need to have power on J21 and J219. Those are the main powers. As far as crank, the crankshaft position sensor signal is in J216. You might need to have an oscilloscope in order to see those signals, because all the multimeter will give you is an average of voltage, but you will not be able to see. As far as the cam, let me see if I see it here, because it might be another, oh yes, right here. J232 is the cam sensor signal. So those are the main players in order for this computer to run. But if you have no communication, I will start with that. I will run just a separate set of wires directly to the diagnostic connector and make sure that you can communicate. Because again, this is not being a problem here. I can start this computer every single time. In the meantime that I'm talking to you, this has been running for 3.7 minutes. I'm going to turn it back on, back off again. And we can see that it's trying. I'm going to turn the ignition back on, fuel pump prime, and it should you see, establish communication back on. If I let it go to the 10 tries, it will say ECM not connected. But since I turn the ignition back on and all powers and grounds and everything this computer needs is there, it will reestablish the communication. So I'm going to do that again. I'm going to turn the ignition off. We're going to lose the communication. You're going to see that in there, synchronizing past 1, 2, and I can let it go all the way to 7. And I'm going to turn the ignition back on right there. 7, and then boom, back on to communication, right? So, and we only have the same 3 full codes. And then now run the computer, and it runs instantly. Not a problem at all. The only fault codes that I have are the 2 coils that I don't have connected, and I do that on purpose. Again, this is a testing procedure that I usually do to make sure the computer logic is good, and I don't see any problems. It says it has a start without warnings, 255, a start without malfunctions, 0, because I had those faults in there. If I run those wires for the coils, which, let me see if I have it here. Yeah, coil. I can run those and reset those, but I know that this is not a problem. Even with 2 bed coils, let's say, this should run and it should communicate, right? So, Rick, I just don't know what to recommend. Again, for the fault that you have in history, I will start by checking the cam and crank signals. I can show you what you need to do. Again, I already give you the pinouts of the signals. So what you want to do, this is for me going a little beyond the test, right? So I right now have the oscilloscope directly connected into injectors, one of the coils, and then the tag signal. So we should see all that happening right away here. And it is. So I'm going to just deselect the nodes. Just need to move this a little bit and change the time so we can see this more here. Where's my signal? Guys in there. I'm in the wrong wire for the coil. That's what we're not seeing anything. I just moved this before, but yeah, now we got everything. We got the ESC signal, we got the tachometer, and the 2 injectors. So I'm going to move the blue channel over to the cam sensor signal, which I have here, and the red channel over to the crankshaft position sensor signal. So now I'm going to turn all the other channels off so we can just see those 2, which is in the red and in the blue. And this is what you should be seeing, right? So the cam should be 50% on and off signal, and then the crankshaft should be all those lines in there. If you want to see more, remember, when you're using the oscilloscope, depending on the oscilloscope you're seeing, you're going to be seeing, you know, that. And then the amplitude of the signals, blue channel is a 0 to 9 volts, and that all depends on what I'm using in here, because I am actually providing a higher voltage signal, so I can change that. Let me just do that. Yeah, if I lower this, and will change the amplitude of that signal, and it does on both, so you will have to check on your boat. This should be a 0 to 5 volts if I am correct, because they are being provided a 5 volt reference from the boat itself. So, and we can see that in here, right? So we can see the signals, the amplitude, everything is good. That's what you need to see, because if you connect a multimeter, you will never be able to see all those windows, again, the square waveforms, and see if they're in synchronization, right? Otherwise, the boat will not run. Again, this is nothing to do with communication. This will just prevent the boat from starting, not from communicating. And this is what I want to stress in there and show you how to do. As far as the sensor, you can use, and this is what I recommend everyone that is a technician on the boat sector to use DICOM. The reason why, okay, I'm going to disconnect from the computer just a second, Because in here, you can go over to the window, look at that arrow, that red arrow right here, and you go over to that book section. And here, this is the manuals. So you can go and select Volvo Penta, Pleasurecraft, Inman, Marine Power, and so on. I will even recommend to, Pleasurecraft. It should be almost the same as in your case. Maybe for, I'm not sure. Well, you got the Crusader right here. So this is the one we're looking for. And then we have the manual for yours, right? So you can do a search with Control F. So we're just going to use Shift, it's Control F, right? So that will do a search, and I'm going to put CAM. This is going to start to look for related words on that, and then we can go into the search, right? This is still loading results. So we can just go cam retard and see if we get the manual for the cam chip position sensor, setting the cam retard. And that also depends on the application, right? This is for the 5.0 and 5.7. So we need to go to the 6.0. All right, so again, this has also the pinouts that I just told you. So we're seeing the J232 as a cam chip position sensor signal. And this is good because it gives you the pinout for those sensors. So it's actually at 12 volts. It's not a 5 volts. It should be around a signal of 12 volts. And we can see that in here. So we have in pin A, so this should be your connector. On pin A, you should have red wire with 12 volts. On pin B, a yellow-black should be the ground for that sensor. And then on on pin C, it should be the sensor signal. Oh, actually, it's right here. Let me just go back to that. So it's actually, you can see that in here. Sorry, because I was reading the 8.1. So 8 is the brown and white sensor signal. B is yellow, black, low reference, again, the ground. And then C is the voltage, 12 volts reference for the sensors, for that sensor. In the crankshaft position sensor signal, you should have A connector, this is the connector, and A, you should have the sensor signal. In the B, you should have the sensor ground, and in C, you should have the sensor power. All right, so hopefully that can help you. You need to check power and ground first. You can use a test light. Make sure it's nice and bright. And then if you are missing a signal, well, then run your wires and see where are you missing. Where, I will start checking the wiring with continuity. You can disconnect the sensor and disconnect the computer, and then provide a test light connected to battery positive and on the side of the computer, which let's say, if I'm checking the cam sensor, right? I already know the powers and grounds and good, but the signal is not reaching the computer. All right, so I'm going to disconnect the sensor, completely unplug the computer. I'm going to go over to the J232, and I'm going to put a cable in there. Well, first, before connecting any cables, I want to make sure that I use my multimeter. I'm going to check it with continuity. That wire to ground, make sure there is no continuity. In that wire to power, make sure there is no continuity. If there's no power, no ground continuity, make sure that with both disconnected, you can check also voltage, one lead of the multimeter connected to ground, and then touch the wire. Okay, no reading at 0 volts, it's not shorted to power. And now you're going to use the same test connected to positive. You will use the negative of the multimeter connected to the battery positive, and then check it in there to make sure that it's not reading voltage. If you read voltage, it's because it's shorted to ground, right? So that's another good way to check that first. If you do that check and everything is good, then you're going to do the next test. You're going to use, again, on the sensor signal, pin A, I will do on the computer, on the connector J232, I'm going to connect this a wire directly to ground.
And then on the sensor, on cam sensor signal on pin 8, I'm going to connect the test light to battery positive. That wire has to be nice, the light has to be nice and bright. Let's say you got a nice and bright light. I'm like, well, you're gonna be, well, it's good. Well, this is, yes, it's good. But we need to do a wiggle test. You're gonna start wiggling the harness all the way close to, vibration areas and heat areas, and see if that light start to flicker. If you start to flicker, I would not poke like very abruptly everywhere, just areas that I need to move and shake. And if you see by any time that the light flickers, unravel the wiring harness and see if you have a pause of like corrosion or shorter wires, and see where your problem is. You can do the same thing for any other sensors, any other signals, everything that you want to check. That test that I just described is the best test to find problems on the harness. All right, guys, thank you so much for visiting the channel. Don't forget to subscribe. See you next time. Bye-bye.